I'm about to give you a whole bunch of information here, so please listen carefully. I'll try to be very careful and succinct with my explanation. So notice at the top it says atoms analyzed more carefully. This is about electron configurations. Electron configurations are the pattern that every element displays with their electrons. So they all have the same pattern, like all elements, as far as like sodium, titanium, calcium. It doesn't matter because they line up, the electrons line up outside the nucleus the same way for every atom. Just a matter of how many electrons there are. So here's what we can do. We can divide the electrons, the way that they line up. We can describe them like almost like a mailing address. So at the very bottom of a mailing address, you have like the most general term, usually what state is the mail going to. So the most general term describes the biggest area. And for electrons, that is called the major energy level. So let me show you what that looks like. So for Roman numeral 1, the major energy level, there we go. is the most general term. There are actually 7 major energy levels, and the first one, where n equals 1, that first major energy level is the smallest and can hold the fewest electrons. So let's keep going here. So energy levels are simply numbered 1, 2, 3, 4, 5, 6, 7. So it goes 1 through 7, starting closest to the nucleus. The higher energy levels can hold more electrons. Okay, maximum number of electrons possible in any major energy level is using the formula 2n squared. So let me put this up here just like it's supposed to be. So that means that if I have n equals 3, then 2 times 3 squared this is brutal, equals 18 electrons. Okay, so that means for energy level 3 that it can fit a maximum of 18 energy levels. Okay, so remember, if we're talking about a mailing address, this would be like the state. This would be the large area. So let's focus in a little bit more. Let's focus in on the town. So the second part of this, like the major energy levels, can be broken up into what we call, does this every time, sublevels. Okay, so sublevels, each major energy level has n number of sublevels. So remember we talked about n equals 3, or the third main energy level. That would be, so sublevels of a slightly different energy. And remember that energy just means distance from the nucleus. Okay, so different energy. Sublevels are identified by the letters. Now this is the one, like these letters are S for the small one, P, D, and F. Okay. Now you notice here it says energy, and that means distance from the nucleus. So every time in every major energy level, the S sublevel is the one that has the lowest energy. The lowest goes right here, and that means that over here we have the highest energy. So it goes from lowest to highest in this direction. Okay. Example, the third energy level, n equals 3, there are 3 sublevels. Okay, those energy levels are 3s, 3p, you guessed it, 3d. Okay, so there's more. Absolutely there's more about this. So far we have the major energy level is the state, which means the state being the largest geographical area, like this very general term describing just about where the electrons are outside the nucleus. Then we can break each of the states down into towns or cities, and that would be the sublevels. Next, we have the orbitals. So the orbitals, another way to say that is orientations. Okay, so the orbitals are parts of the sublevel. Okay, so we've gone from the state, which is the major energy level, down to the sublevel, which is its city or town, down to the orientation or the orbitals, which is like the street address in the city. Okay, so sublevels are divided into orbitals. Within one sublevel, the orbitals are of equal energy and differ only in orientation in space. So every orbital can hold up to, now this is very important, 2 electrons. So the s sublevel only has 1 orbital, which means it can hold 2 electrons. The p sublevel holds 3, which means that it can hold 6 electrons. This ends up being very important for electron configurations. The d sublevel can hold 5, which means it can hold 10 electrons. The f sublevel can hold 7, which means, of course, 14 electrons. Now, if you're wondering why, it doubles each time. Like 1 goes to 2 electrons. So the sublevel, S sublevel, has 1 orbital, 2 electrons. The P sublevel has 3 orbitals, 6 electrons. That's because for every orbital, it doesn't matter whether it's an S, a P, a D, or an F orbital, then it can only hold a maximum of 2 electrons. So up here you see the 2. Okay, so that's why that is. So let's continue on. This is a lot of information at one time. I understand that. Let's keep going. So take a look at what the S sublevel looks like. It looks like a ball. That's it. Just a ball, and 2 electrons can fit in there. And it doesn't matter how big the ball is. 2 electrons can fit in there. Take a look at the P sublevel. Now the P sublevel looks almost like a dumbbell shape. Notice that the P sublevel has 3 different orientations. This is what I mean by orientations or orbitals. Each one of these is an orbital that can hold 2 electrons. 2 electrons fit in here, 2 electrons fit in here, and 2 electrons fit in here. That is a total of 6 altogether. So the P sublevel can hold 6 electrons. Take a look at the D sublevel. Now it gets more complicated. Notice that it almost looks like a clover. So when I say dumbbell, I mean P. When I say clover, I mean like a 4-leaf clover. I mean the D sublevel. D is in dog. Notice the 5th one, though, has a funky shape to it like that. That's just, what can you say? That's what the math gives us. So take a look at the F sublevel, and now it gets really freaky. Take a look at that. So you got some that look like the fifth one from the D and some that look like double clovers here. So we're not going to describe the F sublevel, okay? But that's all 7 of its orientations or orbitals. And each one of these holds 2 electrons, which means the F sublevel can hold a maximum of 14 electrons. Okay, now let's talk about the last part to this. So the street name was where we were for orbitals. What's the last thing we need for to get a letter to a mailing address? We need the actual street number. We need which house it is on that street. And here's the last one. The last one is called the spin. Now, if there are only 2 electrons in each orbital, then the spin is very simple. Okay? And here's what it is. So 2 electrons, which occupy the same space, occupy the same orbital, must spin in opposite directions. So that means that they must spin in, one spins in a plus 1/2, okay, and the other one spins in a minus 1/2. Now the 1/2 designation, that comes from the math, and I'm not going to explain what that is. I'm not sure I even fully understand what that is, but we always show them as plus 1/2 and minus 1/2. So if I have one orbital, I have an orbital, I use a line to look like an orbital like this. As a matter of fact, I'll make this one a P, and I'll have 3 orbitals together like that, and then I can do, typically what I do, let me see if I can draw this for you, make it look good. Yep, nope, that's not going to work. So we use arrows. There's one arrow, there's one electron, and there's the other electron. So if this is the P sublevel, the lines are orbitals, and the electrons are the arrows pointing up and the arrows pointing down, like that. So this is how we show 3p. This would be 3px, py, and pz. Those are the 3 orbitals. Okay, we don't have to name them. We don't have to name the px, py, and pz. But it helps for you to know that there are 3 orbitals in the P. Each one holds a maximum of 2 electrons. They must spin in opposite directions. So you are not allowed to do, you're not allowed to have an orbital that looks like this. This simply would not happen. Okay, all I wanted was a straight line there. So let's try this again. There we go. So you're not allowed to have an orbital that looks like this, where it goes up and then the next one goes up. Okay, that cannot happen. Big X. No. Okay. So here we talk about electron configurations. Now that you have this info, I'll tell you what, I'm going to break here, and then the next one will be about electron configurations.